All right, so far we have talked about the atomic structures and the isotopes. So the last thing that we're going to do to finish out this unit is going to be ions. So we talked about them briefly, but now we're going to actually be able to identify them. Okay, so this is where you would have to fill in some things for your notes. So if we're looking at atoms, they're electrically neutral, meaning they have the same number of protons as they do electrons. Okay, but ions are not neutral. So all of the examples that we've done so far have been neutral atoms, meaning our protons and our electrons are the same. Well, now we're throwing in ions, meaning our number of protons and our electrons are going to be slightly different. So atoms with a positive or negative charge. So if it is a cation, it has a positive charge, meaning we're going to lose an electron. And then anions have a negative charge, meaning we are gaining electrons. So if you're looking at the structure itself, okay, so in the middle, we have our nucleus that has our protons plus our neutrons, and around the outside, we have our electrons, okay? So far, we've seen electrically neutral ones. So that means if there's 4 protons, there's going to be 4 electrons. So right now, this is a neutral atom, okay? That's what we've seen so far. An ion is saying one of our electrons is going away. So if I take this electron and it leaves, okay, so this is now no longer here. So now I have 3 electrons and 4 protons, okay? That means that my protons are now going to outbalance my electrons, meaning it's going to have an overall positive charge because protons are positive. So now this atom this ion now has a positive charge because it lost an electron. So it's kind of the opposite of what you think. So usually you think when you're losing something, it goes down, but because of the charges, when I lost this electron, now I have 4 protons, 3 electrons. My protons, which have a positive charge, and my electrons, which are negative, now my protons outweigh my electrons, meaning the overall charge of this atom is going to be positive. Okay, so as long as you can remember, basically to do the opposite is going to be super simple. All right, so the easiest way to know about the charges is with our periodic tables. Okay, so if we look at these periodic tables, okay, at the top they're going to have positive charges, or they're going to say either a positive or a negative charge. These don't have that, so we need to get something to do. Okay, so but at the top you're going to see certain ones will have certain columns, not the numbers that list it 1 through 18, but there's going to be an additional either positive 1, positive 2, positive 3, negative 1, negative 2, negative 3. Okay, and you'll see that at the top of the periodic tables. All right, so then if we're looking at this as an example, okay, so we're going to work this out the same way that we have been. So if we're looking at lithium, if we are looking at, if we are looking at lithium, all right, so how we have been doing it is the number of protons is our atomic number. Okay, so protons, neutrons, electrons, and then we'll just add ion down here. Can't write today. So my number of protons is still my atomic number always. Okay, so I still just have 3 protons. My electrons in a neutral atom are still going to be 3, and then we would find our neutrons the same way. So we would take our 7 minus 3 gives us 4 neutrons. But our ion, okay, so with lithium, we find it here, it's going to up here, there would be a +1 charge. So because it has a +1, we're going to subtract. So with our electrons and our neutral atom having 3, a positive charge, and I know that just because I looked at the periodic table and there's a positive 1 up here above lithium. Since it has a +1, we're actually going to subtract 1. So my electrons and my ion are only going to be 2.